my data is converged, correct?
Also,
So
yeah, with that condition, along with also a condition of evaluation on test data,
yeah,
it
okay,
gotta go to a local minima, you save, and then the error start increasing cost function value. So we have to stop precisely that point where it start going up. So we want to reach to the lowest of the cost function value for given
okay,
thetas. And
but
if we
given
keep
data,
continuing
okay,
doing that, then our theta will start, going increasing, ha- taking us to a higher value of cos theta, which is cost function
okay,
that we do not want. So maybe I'll share
okay,
my screen and then,
yeah,
yeah, so just see you. So before going ahead, point option pan, this we want. So we are training on train data, then we have test data.
yeah,
Eventually what happen when our training will increase over the time, we will see
mm-hmm.
this is loss means error. For
Yeah,
training it will start reducing. The same will start happening here when at some point the change in the loss, the delta loss,
yeah, yeah,
delta loss would be very minimal. So you will, when this happens, you will start seeing these things, but it starts fluctuating likewise, which is kind of a plateau, or flatten it, what we say. But here the test function, when we see that, it will start going down, and one point will come, then this error will start increasing. So that is the precisely the point where we need to stop. So over the test data. So evaluation on the test data is always required.
right,
Now
okay,
how we figure out that it's converse. So we always look at the loss function, loss value. Loss means error. So there are many techniques which I discussed. One of the techniques was that they will see how is the delta loss. If delta loss eventually is very small, for example, so it means that there is now no change in the loss function. Therefore we will stop at that. So early stopping is one of the technique,
early stopping, yes,
right?
yes, exactly, yeah,
So this is one of the way where so where we stop the trading, and that's we keep on doing
keep
until
on.
we reach at this point.
Okay, so
Yeah.
the action of the activity of using what I'll say, doing the early stopping will
Mhm.
decide the convergence, right? So not just that, okay, my training data is flat,
Yeah.
and then when it's
Yeah.
up like a flat line,
Mhm.
that doesn't mean convergence. So even the repeatability of that
Yeah.
uh, from the early stopping, like a function where you mentioned a
Yeah.
checkpoint stuff, so that will be deciding whether my the data is converging or not.
Yeah, so maybe it happens that train start going plateau, but here there is a scope of going it down. So
Down.
if,
Okay.
if if this point is here, we reach somewhat here, but still I am seeing this values are going plateaued, but I am seeing still there is a drop in the loss function. So I will not stop here. I will let it go. One point will come
Understand.
when it will start. There would be some plateau and then start going up. This is the point we stop. You stop here, you stop here. Every point is good. So corresponding, the thetas corresponding to these all the points are the best set of points. We can choose whatever. So, so early stopping is just that by coding way you do some math. It's just a function which just looks is that how is the change in delta. That is it. Now and okay. So before going to this another algorithm, now I told you the algorithm gradient descent. The objective of telling this algorithm was that this is the pure uh, algorithm which lies under the area of machine learning. Now what happened? But there are another field. There is machine learning field. There is another field, statistics. So in this field, now, you must have heard of now. Or there is normal equations. So normal equation is a solution which says that if you have provided me, so this is nothing. This is transpose x transpose theta y. This is the way of representing in vector form. So that's would be okay with n. Theta n equals to y. So we can write this thing as x transpose theta, a vectorized form of writing theta 1, theta 2, theta 3, x1, x2, x3 up to xn. Row number 1, 1, 1. So I'm just saying that in statistical way, solving this equation, there is a direct method which can help you calculate thetas. So you will see if you are going with a statistical way of solving this linear regression, Only linear equation, I'm not talking about other algorithms, only linear equation can also be solved with the normal equation. Now, what is the benefit of normal equation? Normal equation will also give you the theta, which takes you to a local minima, but normal equation is very, very fast. So in general, if you see any linear equation implemented in machine learning, they have done it via normal equation. But the agenda, overall, the idea is same. So therefore, instead of focusing on the normal equation via statistics, I focus on the gradient descent, because this is you are supposed to know that how we achieve this is how we achieve our local minima. But having said that, normal equation is something which is already existed in the statistics before the machine learning came into the place at this level, which is capable of solving these problems, where you are given x1, x2, xn, all the parameters, you are given y, which is our ground truth. Then based on that, find me the best set of thetas. This thing can be done by normal equation, but this is just for the theoretical knowledge that there exists something else too. So but we will not go into that, into the understanding of this thing, because that's not the scope. We would be relying on the machine learning side. So therefore the gradient descent was must to teach. Okay, so having
Yeah.
said that, hmm, so
Sorry,
just yeah.
sorry,
Mhm.
one short question before.
Yeah, yeah, please.
So you in the linear like regression with or the gradient algorithm with multiple features, right? So you mentioned about the encoding with different variables. So like
Yeah,
if we have some strings or characters which will
yeah.
have
Mm,
to be like sort of given a numerical to it.
yeah.
So you mentioned that there are like for example uh, a equal to 1, b equal to 2 and 3,
Mm,
but by
mm,
default the algorithm could be biased, so that we are converting that into a vector form, like or
yeah.
like
In a
or an array.
in the array of one hot form. We call it one hot form, but what we are mentioning, that's right. So
So
if
but here
yeah,
the
yeah.
confusion is like if we let's say if we have certain
Mhm.
features which will from the data set, if there is a higher weightage which must be given, but in the array you directly took them as only ones and zeros. So I didn't get that the example.
I got your point.
Yeah, how do you
So
directly
so
correlate those?
this is our column value, something ABC. We
Yeah.
cannot use ABC. We need to convert it to some numerical form. So one way,
Yes.
which was that, which plainly comes into our mind, is that give it one, give it two, give it three. Right now, this gives us some biasness that C is better than A, but maybe this is not the case, right? There
Yeah.
could be the case that giving 1 2 3 is directly not right. So we decided we will make it one hot vector. This is known as one hot vector, because in this vector only one bit would be on. This is kind of a bit. This bit is
Yeah.
on one, this bit is off, this bit is on, like that. Now this variable now would be reflected in the algorithm as, suppose this is column x, sorry, let's name it x2. Suppose this is x2, so this would be right. Ideally this would be q2 x2, theta 2 x2, but we cannot write x2, so this becomes 9 theta 2 1, where 1, theta 2 2, where 2, theta 2 3, where 3. So a separate theta will be assigned here. So these thetas are gonna train based on this thing. Did you get my point? So we are not sharing theta. We are having three thetas, which are break based on these variables. Now, if this bit is on, it means this theta 2 1 has the importance here. So variable one has the importance. This becomes 0, right? Which eventually tells you this is A. That's the agenda.
Okay. Okay. It means like the characters whatever are there, which may still be of higher influence, but uh, we are giving a numerical in such a way that the algorithm will not be biased.
Algorithm
So
will not be
every
biased.
time, and
So
that
it's
that
just
every
one one one. Yeah, please.
no understood this
Yeah,
point.
so it's just one. So we have all, there's no, everything is one. We have reduced the biasness. So if this variable one value needs to be taken, which is A, this bit is on. So the corresponding theta would be on, variable one would be on, and this becomes 0. So model understands that, okay, we are talking about something whose first bit is on one, which is basically nothing but the A. So this is kind of a representation. We call it one hot encoding.
Okay.
Or these variables which we have incorporated here, these are known as dummy variables. Because they are dummy variables, you have introduced it in the system. Now last thing, since here if we are mentioning here 1 0 0 0 1 0, for example 0 0 1, therefore it is already understood that if this is 1, rest are 0. If this is 1, rest are 0, because this is one hot encoding, only one would be on. Therefore there is no need of writing this thing. So 0 0 by itself means neither A is on, neither V is on. It means we are talking about C. Why we do that? We do that to save one variable or remove the multicollinearity, because this is also kind of a multicollinearity. These two variables are sufficient to tell you whether it is A, B, C. So third variable is redundant, and we always reduce redundancy because this brings multicollinearity. So keeping any two dummy variable is sufficient for categories. For example, if this column, whatever it is, if it is a n unique values, then only n minus 1 is sufficient to represent the n different values. If they are A, B, C, D, so only three hot encoding is sufficient. If it is 4, 5, then only 4 is fine. That is it. Because this brings this information is redundant. We can derive just based on these two value, whether it is A, B, C. So yeah, that is it. So okay. So before going to this linear algorithm, let's summarize the linear regression or any kind of summarize the formulation of any machine learning algorithm. So initially we decided that we would be having some objective, what we want to achieve. Based on objective, we figured out the hypothesis. Hypothesis or what we want. We want y predicted values, which is nothing but should be something like theta 1, theta 2, and so on. This we decided theta n, xn. Then after deciding this hypothesis, we decided okay, we need some relation, some cost function. That was the objective. In linear regression, we decided this is gonna be squared error, mean squared error, mean squared error. After that, we decided okay, algorithm application algorithm, reduce this cost function till we reach the minima and we get the corresponding thetas. That's the agenda. Now, keep this thing in the mind, and this is how we're gonna formulate our this algorithm. But before going that, let's understand what is the objective. Okay, so far we the problem which we solved in the linear regression was mainly for the continuous data. Why continuous? When we are talking about salary, talking about price, these are continuous data in the decimals, floats, double. So we trying to predict which the nature of the data which we try to predict is in the form of continuous data in salary, continuous data. But now we want to do we want to do some predictions which takes some discrete values, either 0 1. So basically you want to do some predictions which basically doing nothing but the classification. For example, we are working on a solution where you are supposed to tell the new guy for to whom you are going to give the loan, whether he's going to default or not. So this is one kind of classification. You are classifying between them as a defaulter or not defaulter. You are doing some online transaction, but now you need to tell whether that transaction belongs to the category of legitimate or fraud. So what are you doing it here? You are doing a classification. You are classifying it into some classes, and these classes, these classes are nothing but in this case whether it is a fraud, I mean genuine or fraud. A email which you receive, whether that email is a spam or not spam, right? You are looking into the images of lungs, for example. There's a lungs image, you see there are some, you need to tell there are tumor, whether that tumor is a malignant, whether it is a cancer or that's okay, a normal tumor. So that's the classification, right? So this when we are solving such kind of objectives, you basically are now dealing into the area of the problems which are known as classifications problem, right? So any doubt in that? When we say that we are looking into a classification problem, here it is. You are just your y variable is nothing but a class. It could be 1, it could be 0. If it is a based on the objective, the four good objective I mentioned here, you are giving a new guy a loan Bankers initially will check what is the chances that this guy will default in the future, or this could be a probable defaulter in the future. That's one. It's up to us that whether we call it 1 or 0. But idea is that this is gonna be some kind of class. Defaulter, not defaulter. Yeah. So in general, when we so first understand this thing. In linear regression, in the salary, our data was some real number. It could be 10, 10.0, 10,000.0, some real number, right? But here in the classification problem, at this moment, our class output is gonna either 0 or 1. By 0 means it could be anything, whether this guy will not spam, or this mail is not spam, this mail is spam. So in general, for the cases where the case is relevant, it's a spam, fraudulent transaction, cancer, tumor, that's positive class. We call it positive class because that's something which we want to classify with. Or anything which is normal, we call it negative class, right? We normally say we see some results in the report, and we say that for example, some tests happen and we say that results came negative. That means okay, tumor, the person didn't find the tumor, so that's okay, that's negative, zero class. But the result of that report is positive, so they found tumor, that's a positive class, right? So that's the in general we do the we do some number encoding 0 1. It could be otherwise as well, 1 0, but just to align with the naturals, the real world, this is what a positive class means, right? Our goal is to find the spam mails, not a spam mail. So no, spam mail is a positive class. But in general, a classification problem in which we've tried to predict whether what is going to be the class based on the objectives. So these are some different objectives, right? So how the data so you're going to have the data, right? Your data could be same, x1, x2, x3, x4, and then you're going to have y. So I'll take an example here of the loan defaulter, right? Or best example, whether you will get a credit card or not, right? Or whether you will default the credit card. So what could be the features? Your age, it could be your age, your salary, you live in a rental house or owned. Just example, are you married or not married? Some examples. So again, remember these are categorical data. Rental, married, these are categorical data. These needs to be encoded, one hot encoding. Salary is already discussed. How, did you default, how many times you default in the last 6 months? This could be a one future, and all the informations of you as a customer would be collected by the bank. Or your credit card score, that is one info, this credit score, that's another information. So they're gonna have all the informations in the past. Also they're gonna see if this was the data, this guy defaulted one. If this was the data, this guy not defaulted. So this is how your data gonna look like. This is in general, our general data looks like here. All the futures, future means again x1, x2, traits, these are characteristics of the person, of the data points who are the part of this experiment, and the corresponding ground truth, it could be 1 0, right? So right now we are just dealing into two classes. Either a person will spam, either person will not spam, 0 1. So we are just classifying into two class. So when we are do that, that problem is known as binary classification. You are binary classifying it either into 0 or 1. There are many problems where we do it on a multiple level. I mean, the problem, the why lies into maybe this could be 0 1 2 category. For example, some problem where we say this is a good customer, this is a bad customer, this is this, I mean, this is very good, bad, average customer. So here this is a three classes. So you are now dealing into, you are not just doing binary classification, you are doing it onto multiple level, multi-class classification, right? This is binary class classification, short form binary classification, right? So guys, so far, any question in the understanding of classification problem, these are examples, and understanding of this thing. Just give me a next.
Raj,
Yeah.
binary,
Hmm.
sorry. So binary classification, this is one of the type, right? Because there could be, as you said, for example, in the spam mail, it could be spam or it could not be spam as well. So there always lies a uh, so when we conduct the test, any test case, there are three results usually. One is pass, other is fail, other is not conclusive. Maybe some additional information is required. So we are not kind of looking into those kind of categories right now, right? When
No,
we talk
we are
about,
we are not looking at. So right now,
okay,
yeah, perfectly. So just to understand that we formulate our problem is that the y which we have, that is concrete. Either that's 0 or 1, right? So there is no third class, for example, not
right,
applicable.
okay,
So we do not know that. Right? If there are some classes where we do not have any conclusion, we will not use that in our experiment because that's not going to help us. However, later when we are solving a problem where we want to classify it on the multiple front, not just 0 1, where the output could be like classify into class A, class B, class C, class D. So here we are classifying into four class, for example 0 1 2 3, four classes. That's a multi-class classification. So but in general, uh, so far we are just discussing about 0 1. So some good examples are that, yeah, just to understand. But rather next algorithms you gonna see the algorithms which do not just binary classification, which classify onto multiple classes. So we're gonna see that. Okay, so anyone before going and understand the mathematics, just can someone answer that why? See, we already we got x, we got and all the x's, all the futures, we have the theta associated. So why cannot we use it in a linear regression? Eventually, 0 and 1 are also some kind of numerics. It's not continuous data, I understand, but these are also numerics. So why do not just apply 0 1, apply the mean squared error, right, and classify and use that linear regression to classify classify them into 0 1. So can anyone take a minute and think?
Sorry, I didn't get your question.
uh
Yeah.
so
So
you want to classify whether the loan gonna be defaulter or not, but why we cannot solve this problem using linear regression?
Okay,
uh,
okay.
honestly,
because
this was the
maybe
first.
in the linear regression we try to find the minima whereas so that would be closer to zero, so but we want to here look into the one value, that's why maybe we need to,
So that's the part of hypothesis where you want your j cost error to be close to 0. So that is something different with this classes 0 and 1, right? So consider all the points I spread here. So can we use linear regression to solve?
So,
Yeah,
that
please.
honestly, no, first of all, this was the first question I had in my mind. Why do we have
Uh,
a different method? But
algorithm.
what I understood is like here in case of a linear regression, so
Hmm.
we are trying to predict data from a continuous variable. Like you have a data
Right.
which is flowing continuously. So we are trying to sort of get the best fitting line or a function which will have a least cost function. But in
Right.
case of a classification, it is just like yes and no. So
So no.
there won't be any continuity. It will be like sort of discontinuous data.
Yeah. Yeah. Mostly overall on a higher level, this is the answer. But yeah. So anyone else, then we go. We will phrase what Gita says into technical way. Okay. So see, eventually you want to decide something into 0 and 1, but from the point of machine learning doesn't know what is 0, what is 1, any algorithm. We always deals in the probability, right? So the probability that person is gonna default is 90%. We gonna say that that's a class 1, class A. If probability that person gonna default is just 25%, and we keep the threshold suppose 50%, we gonna say this person will not default. So first thing first, we want some mechanism which deals in probability rather than finding the continuous value. So we want to bring something into the picture, because for example, your y equation is nothing but all the thetas 1 x1, theta 2 x2. If this value comes out to be 1000, will 1000 be able to tell you, I mean this number suppose this comes out to 1000, so how you will be able to relate that 1000 is close to class 0 or 1? So that was the biggest problem. I mean there is no what we do in general, the y hat we
So,
calculated. Just let me finish and
so
then yeah, please. Yeah, what I was saying that in linear
please.
regression you multiply thetas with the axis. These thetas are figured out, and then you finally receive some continuous values. So suppose for one row we get 1000. Now is there any way you make a relation that if it is 1000 I make it 1, if it is say 800 I make it 0? So that was the biggest problem. Now tell me please.
Okay, maybe these two are different problems. Means this classification and this linear regression. They are dealing with totally two
Two
different
different
Two
problem,
different
domains.
category of.
One is
two different
probability,
categories.
and one is like predicting some
Yeah,
maybe analog value.
yeah, you are learning supervised algorithms, but the nature is different. Here you predict continuous values, right? Here you predict discrete values 0 1. This area is more about probability, right? So one example 1000, maybe second row, this is first row, second row you get 2000. Now, is there any mechanism? There's some hidden function which tells that if it is 2000, this is class 1. That's the biggest challenge. There is no linear regression. We cannot relate these numbers with some probability or some class. So that's the one challenge, right? That's the biggest challenge. That there is linear regression doesn't help you convert the y hat into some classes. You never know that. So that's the point which we need to find out how we can do that. So that's the objective. That's what linear regression will not help you solve this kind of problem. Second thing is more technical. It's okay. Mean squared error. My y is my y is 1. Y hat, guys, I don't understand. My actual y is 1. This guy will spam. My y hat always gives data in the continuous form. It gives 1000. Now you can understand 1000 minus 1 ka square plus say next value was 2000, class was 0. 2000 minus 0 ka square. These numbers are gonna very huge. So mean squared error itself is not a suitable cost function to solve this problem. Right? What we do, we always do y minus y hat ka square. This we want to reduce, but it doesn't make sense in this class where my y actual ground truth is class 1, class 0. So this will not help. 2000 minus 0 ka square. This is not taking you anywhere, right? So that's why the two things, the multiplication theta 1 x1 will give you some continuous value which has no relation with 0 or 1. No apt way to find a relation. Second, mean squared error is not a great way or actual way to classify something into the class. So this boils down to three aspects, right? Objective is clear. Second objective is to create a hypothesis that we want to do, basically the by head. Find the cost function, right? That's why I initially mentioned that we're gonna do same thing like we did in linear regression, but we're gonna work on the hypothesis, we're gonna work on the cost function. Once we figured out the cost function and hypothesis, things are very easier. After then we're gonna apply gradient descent, right? That is it. So let's do that. Okay, before that, and some normal graphs I want to take you here. This is our by logx graph. So logx graph is such that if the values are between 0 to 1, if you move towards 0, the value will go to the infinity, minus infinity. However, if you move to makes value greater than 1, it will keep on going like this way, right? This is log x graph. Y equals to ex graphs, exponentially increasing. After 1, the value will shoot exponentially. This is e raised to power 1. For example, e raised to x. For easier, let this is exponential of e. Let's take it 10 raised to power x. So 10 raised to power 0, 1, 10 raised to power 1, 10, 10 raised to power 200, 10 raised to power 3000, so on. These values explode very fast. These two graphs, I just wanted to just keep in mind the nature of y equals to e raised to x, y equals to log x to x. This is how it is, right? So so nothing to be memorized here, just an idea. Okay,
Raj,
we are trying.
before we
Yeah,
go ahead, I just want to clarify. So in the linear regression, we were finding the value of, or we were predicting the value or cost of the house, for example, which cannot be predicted in either zeros or one. And that's why we have come to this new types of
yeah, yeah. So you
regression, right?
yeah, in linear regression, you were right. We were predicting
Yeah.
something which is continuous in data.
But it was not, it cannot be. So when you say it's a discrete value, it cannot be in zeros or one. So any value which cannot be zeros and one, that the or that can be in those cases we can use linear
And
regression. In some cases, maybe
okay,
in
so
future,
yeah,
yeah.
yeah. So you will understand with this graph. So suppose this is the y in linear regression, right?
Mhm, mhm.
If you plot all the y values, so y value somewhat will lie like this, right? Just y
Right,
value,
right.
right? 10,000 but if your y value is just 0 1, you're gonna have just two values, right? One value 0. So,
Okay,
right, this 100 people have value zeros, 2000 people have value 1, so you're gonna have just two value, right? Two
okay,
data points, that
yeah,
is it.
yeah. Okay.
So this nature of data is called as discrete, and this nature of data is called as continuous when we have your continuous data, right? Yeah, so that is what is happening. Yeah, so yeah. Okay, so linear regression, if last summary, if you solving any problem where you need to predict something which is continuous in data, of 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 some real number, it's okay. I mean, it could be 0 to between 0 to 1. You are predicting some value which is on the scale of 0.001, 0.1, 0.2, 0.3. Yeah, but they're continuous. So if we do such kind of solve such kind of problem, that's linear regression. But when we want to classify them into some classes, 0, 1, spam, not spam, these are discrete values. So that comes under the under the area of classification, known as classification problem. And logic regression is one of the algorithm which helps solving such kind of problem. In future, I mean, there are multiple problems which can solve these equations, but this is must. I mean, it's must to understand linear regression for continuous data, and logistic regression for discrete data. But after then, you're gonna see the algorithms which works on both. But okay. So having said that, we are trying to solve the binary problem using linear regression. Okay. So guys, before that, tell me basic probabilities. Uh, for example, probability of coin. Probability of coin. Uh, if we are tossing a coin, probability of coin getting a heads is what? A probability of coins of tail. A very basic question. Let me. It's just half. Whether it ends up heads, whether it ends up tails, it's half half, right? I gave you three coin. I just want to. I gave you three coin, and I asked you, toss three coins together. It's what is the probability? It's ends of heads, and tail. Can anyone tell me? There are three coins. Uh, we uh, throw it parallel at once, and finally they ends up with heads, and this one at tails. What is the probability of this event? Chances. Can anyone tell me?
1 by 8.
1 by 8, perfect. And how did you come up? You just multiplied, right?
Yes.
So basically what you do, you read p dot h, p dot h, p dot t. This is very intuitive. I mean, this is very intuitive. But this intuition has a well-defined mathematical proof that why you can multiply it. And this thing is known as independence. This says that independent theorem or independence just says that this event, tossing this coin, has no relation with this, and tossing this coin has no outcome on this tossing this coin. They all three are independent of each other. The impact of one will not have the impact on other, right? So they are independent in nature. And machine learning problem, not machine learning, in probability, if these events has no relation among each other, basically they are independent of each other, you can straight away multiply their probabilities. That's why probability of head is half, probability of head is half, probability of tail is half. Plus 2 1 by 8. So very intuitive, very easy. But what I want to the information I wanted to convey is there. I mean, there is a long proof behind that, that why we can multiply it. I mean, this is totally in sense that we can, we know multiply that. But why we were able to multiply that? Because of this reason. Having would it have been the case that these events are independent on each other? You cannot multiply that, right? So I'll give you one example of that. uh there is a dice is marked with 1 2 3 4 5 6. There is a box, and you got not 10, not dice, you got 5 blue marbles, 5 green marbles. I give you one attempt. Take uh take one, these there are 5 green marble inside and 5 blue marbles, some balls. I asked you to pick one coin out of that. So you can pick any one. Then I asked you, now pick second marble. Give me the probability that that the first is gonna green, second is gonna blue. Right. Now there are two cases here. First case, you take the first marble out, and then you do not put that marble back into the box, and then you take the blue box. Now first you pick green, probability would be 1. So there are 5 blue, 4 green. Probability of green is 1 by 4. Probability of blue is 1 by 5. Now there could be case that first green marble is inside the box. You took the green marble out, right? You put it back, then things are different. Since you put it back, probability of picking one more green marble would be again 1 by 5. So for example, if I'm solving these cases, green, first green would be 1 by 5. I take the marble, put it out. I now pick another green marble, that's 1 by 4. Probability is 1 by 20. Now I there's a case in which I put the marble back into the box. Then the probability of second green marble would be 1 by 5. That's 1 by 25. So probabilities are not different. Why? Because the second event is dependent on the first event. So they now are not independent of each other. I just wanted to convey the meaning of independence, where the impact of one event is dependent on the another event. So in this case, these coins, throwing these coins has no relation. It's okay. If this is the case, you can multiply them. But if one coin or one event depends on other, you cannot directly multiply them. So but so only this point we need to learn. The probability of events or scenario would be, if it is H that would be probability of H dot probability of T. Why it is possible? It is possible because of independence. So only this point I need to take you in the mind as of now before going forward. So this is yeah, that is it. So let's start making making the hypothesis first. We know that we want to come up with some hypothesis which is nothing but the y hat, and I wanted you to, this y hat should be such that that value lies between 0 to 1. This is what we want. I want that my y hat ka value should be between 1 and 0 initially. This is what we want. This hypothesis we want to work upon. Now, before going that, is there any way which can help us, this is y hat. Y hat nothing but hypothesis. This is nothing but x1 theta 1, x2 theta 2, x3 theta 3, xn theta n. This could be something. Now I want some kind of, some kind of change in the y hat which makes your value and bring it into the value range of 0 to 1. This we want to achieve. So that if you do that, your problem is solved. Your problem is solved. Now this is achieved with the help of, I'm going to take you the very first function, which is known as sigmoid function. Some of you must have heard of. If no, I mean, this is a very very simple function. This function is given by 1 upon 1 plus e raised to power minus z. Let's not go into the what is z. I just wanted to show something here. See, uh, I'm just here. Let's forget what is written here. Let's forget what is written here. This focus on this part. 1 upon 1 plus e raised to power minus z. Suppose if I put z equals to 0, guys, so equation becomes, just try to understand, and then everything will boil down. E raised to power minus 0 is 0. E raised to 0 is 1. That becomes 1 by 2. So it says that this is z. If your z is 0, the output of this function would be zero point 0.5. Now put z equals to infinity. This goes to infinity. This goes to minus infinity. Then 1 upon 1 plus e raised to power minus infinity. This will become 1 upon 1 plus 1 upon e raised to power infinity. As the graph says, that's why I told you e raised to power infinity is infinity. That's why we saw this graph. E infinity is infinity and 1 upon infinity is 0. 1 upon 1 plus 0 is 1. So as you move towards infinity, this value will go max toward 1, never crosses the 1. Now let's go this side back. Put z equals to minus infinity. So when you put it minus infinity, minus infinity, e raised to power infinity is infinity. 1 upon this whole infinity is 0. So this means as you go towards minus infinity, you will reach max 0. So your ranges become 0 to 1. Now did something start striking into your mind that somehow we are reaching, we bring uh, some function which is able to bring your whole numbers into 0 to 1. Now what scientists did that 1 plus, this is the sigmoid function, they replace the z by nothing but h theta x, which is nothing but x1 theta 1 x2 theta 2. So just be with me here. So what these guys are doing, initially you calculate y hat. This you're already doing into the linear regression. Theta 1 x1, theta 2 x2, theta n xn. I call it y hat or I call it z, for example. So then I'll put it into 1 plus e raised to power minus z. And this thing boils down to g raised to z. So which will bring your value into the range of 0 to 1. So guys, what they did, they calculated y hat and put it into the sigmoid function here. And when you put it number, how bigger this number or how smaller this number, I showed you the two cases, infinity minus infinity. The ultimate gz value, the sigmoid function results will boil down to 1 and 0. So this way we are able to bring our output into the range of 1 and 0. So at least we decide the hypothesis that what is gonna be my new hypothesis. So my hypothesis is gonna be nothing but sigmoid function of the y hat, which and this is not a new function, this is already been there. So now you can understand the beauty of the sigmoid function, that how simple it is, that it brings your whole in value which lies from minus infinity to infinity into the scale of 0 to 1, and that becomes our hypothesis. So guys, any doubt in this sigmoid function? So I'll make the graph here clearly. uh, just a moment. At 0 the value is zero point 0.5, towards infinity value touches infinity, goes, the graph goes like this. This- Now this pen is not working, or this is the graph. This is zero point 0.5. This is range is 0 to 1. This value is infinity. This value reaches minus infinity. These values are nothing but y hat, which is theta 1 x1, theta 2 x2, theta and xn. This value has to be put in this graph, 1 plus e raised to power minus z. We call it z, common representation. This is gz, the sigmoid function. So in general, sigmoid function is a function in which if you give some continuous value, it will put it into the range of 0 to 1. So the output would be like somewhat 0.45, for example, 0.25, 0.75, but it will always and always gonna remain between the range of 0 to 1. So that's the second question when we say that it is still not 0 and 1. But as of now, everything boils down to the range of 0 to 1. 0 to 1, right? So guys, any doubt here? Or any, I can even repeat again, the sigmoid function, somebody wants to understand the sigmoid function, or it is clear?
Uh, partially, yes.
Yeah, so it's okay, I'll repeat once again. Just try to be with me and stop me right there if things at least not making 50% into our mind. So guys, then the y hat is okay. This we can do, right? Now we wanted, our main next task was that we wanted some hypothesis which is capable of converting the y hat into the range of 0 to 1. This we want. I mean, give us some function. We asked mathematicians, that give us some function which is capable of bringing this thing into the range of 0 to 1. This is our objective. Now we tried a lot of function. Then the researchers came out to, then after some researchers, sigmoid is the name of, I think, the researcher who gave this function. That's why it is called a sigmoid. But still we can correct it. So he gave this function which is nothing but 1 plus e raised to power minus z. And again, I show the beauty of this function. We take three values. Let's say 0, let's say infinity, minus infinity. Why? Because the multiplication of all the thetas with x1 can be max up to the infinity and least up to the minus infinity. So we are basically covering all the cases. So in this function, let's 0 is the case. Suppose this value comes out to be 0. Put it the 0. So when we put e raised to power minus 0, simple mathematics, minus 0, 0, e raised to power is 0, 1, and 1 upon 1 plus 1 is half. So this is the half. This is the center point. Let's put it infinity. So when I put it infinity, this whole thing boils down to that 1. So it says that if my multiplication of theta x1s reaches to the max of the last infinity, the y, the output gonna be the 1. So it will never bypass 1. This is max. At infinity, it is gonna 1. At minus infinity, very far, it is gonna be 0. So we, this whole experiment, the sigmoid function, boils down your input into the output of 0 to 1. So sigmoid function, your input boils down to the output, which is in the range of 0 to 1. This is what we were thinking on a higher level. This is objective. We wanted some
Yeah.
hypothesis of function to be there.
So, so basically, we just want to bring down any number to either 0 or 1, and the sigmoid function will do that, right?
Right, sigmoid function will do that. Sigmoid function will
Yeah.
give the value to 0 to 5, 0.5, so on. Now, after this, now what we do, the second step. So we need to decide the threshold, right? In general, the threshold is 0.5, 50%. So if my threshold, the value of the sigmoid given the input of the output, if it is greater than zero point 0.5, I'm gonna predict this class as 1. If my value is less than zero point 0.5, I'm gonna predict that class as 0, not spam. Now you say this zero point 0.5 is not always fixed. It depends on the business objective. For example, I'm creating a problem where I just wanted to be sure that the patient has tumor. So even if there's the slightest chance, so basically we are working in a scenario where we want to be very pretty sure that the patient has tumor. So what we want, you want your threshold to be higher. So I would say that if the output of the sigmoid function, say threshold is I 7.75, then I will classify into the class of 1. Less than 0.75, I will put it in the class of 0. So it just plain depends on the threshold you choose. In general, the threshold, if you do not give it by yourself, it is considered as zero point 0.5. Any number above zero point 0.5 would be classified into class of 1. Lesser than that, class of 0. But again, threshold is threshold. We can vary that according to the nature of the problem. If so just perfectly predicting a customer, not customer, the patient having a tumor, and we want to be precise. I mean, our cancer patient having tumor is gone through a chemotherapy, so you cannot give chemotherapy to a person who do not have cancer. So you have to be very precise. Just an example, in this scenario, I want threshold to be on a higher side, so I can keep it 0.75. Just an example. So this is how we boils down everything. So we calculate the sigmoid function, sigmoid value, using a sigmoid function over the h theta x, which is nothing but the y hat. We applied sigmoid on top of that. Sigmoid will give us some value, say some value. Well, if this is greater than equals to threshold, I put it class 1. If it is less than zero point 0.5, I put it class 0. This is a simple conversion of based on probability. You're converting them into class 0 and 1. So far, summary, sigmoid function, as you mentioned, sigmoid function helps you bring the value into 0 to 1, and anything between 0 to 1 is nothing but the probability. That's what probability is, right? So that's the.
So
Mhm.
just one comment, the threshold value that we decide, it depends on the inputs that we have, right? So
Objective.
nature of input will
Na- na-
decide how much threshold we want to set, right?
not nature of input, the nature of problem you're solving, the objective.
Okay.
If you're okay, so yeah, so I given a very critical example here. But if I'm a doctor whose mindset is something different, I do not want even some patient, if I want capture all the patient, whether they have a tumor, I do not want to miss anyone, then I will keep the threshold on a lesser side, say 0.45. So it just depend on the problem which we are solving, right? So on that basis of that, you will put the threshold. But if you do not put it by yourself, the system by default will take zero point 0.5, the machine learning algorithms, because that's the general 50%. Anything above that is 1, anything below that is 0.1, 0. So with that, with the understanding of sigmoid function, how it is capable of bringing the humongous continuous values between the interval of 0 to 1, we're gonna work onto the cost function, right? In linear regression, the cost function was mean squared error. But as I already proved, that mean squared error is not a very appropriate cost function for this problem. So we would be working into the finding of cost function here. So okay, so with that, let's see. Uh, this is the data. You already have the data. These are data points, training inputs. Hypothesis is now clear. This is the hypothesis. Uh, uh, Minus theta 1 x is nothing but y hat. Y hat is not saying y hat is not the right term. It's just multiplying by theta 1, x1, and so on. It is a vectorized form of writing that. Theta transpose x is 1 upon 1 plus e raised to power minus z. Instead of z, we put the theta transpose x, which is nothing but theta 1 x1, theta 2 x2 up to theta n xn. How to find the best parameter theta? That's our goal. So let's try to understand that thing here. So this looks hard, but this part is gonna be very easier. So guys, as I mentioned here, initially I tried to solve this thing. Experiment 1 had, experiment 2 had, experiment 3 had. We toss all these coins together. I told you that we can multiply their probability, probability of head, probability of head, probability of tail. Why? Because all are independent, right? This is an assumption that independent. So before driving the cost function in logistic regression, in this algorithm, we make one assumption. What the assumption which we make? All the data points means row 1, row 2, up to row n. All the data points are IID. IID term means they are not individually is not the right word. They are independent among each other. That's the assumption we make. That this row 1 ka input has no effect on row 2. Similarly, row 1, whatever the data which we have collected, they all are independently collected and independently distributed. So they have no relation among each other. So that's the assumption which we have to assume while solving this problem. The data जो भी हमने collect किया है, whatever the data which we have collected, they are purely collected as an independent experiment. They are not related to each other. So given that assumption, we will proceed. So let me write assumption. All the data points are IID. This is a short form. In simple, independent of each other. That's the assumption. With that, with this assumption, so let's write it this way. So we have all the points here: x1, x2, x3, x1. Let's try to understand this statement. Simple. It, everything start making sense soon. This says that this is nothing but given. Given the input x and the theta, this is already given to you. I mean, we assume given some theta and the x, the probability of y is this thing. Let me tell you how. Suppose given x, if y value is 1, right? So let's put 1 here. Let's put 1 here. 1 minus 1, 0. This whole thing's become something raised to power 0 is 1. So this boils down to just x theta x. So let me write it here. This is the just way of writing the notation. Probability of y just 1. Now suppose y is 0. So here this y we put it 0. This is 1 minus y. 1 minus 0 is 1. This terms become 1. So probability of y given x theta, जब y 1 था, जब when y 0 था, this becomes 1 minus h theta x. That is it. Now assuming, then we generate one term which is known as likelihood of the parameters. So actually what we wanted to understand, given all the data points, what are the likelihood of the parameter, which means that what are the chances that these all data points has given this y value for this set of x, this set of y, the thetas are the most probable. I mean, I want the best set of the thetas for which this combination exists. X, Y, X, Y. I want that theta's likelihood for which this combination exists. So for that, what we do, we multiply the probability of all the data points. For example, probability of row 1, probability of row 2. This is nothing but the example of probability of H, H, T. I multiply all the rows, all the examples. Now, since we have assumed already they are independent, therefore I am multiplying. So that was the reason why we assume all the examples are independent. So consider these data is nothing but the example events. Here the case was just HHT. Here this is the same thing. I mean, this is also an experiment, right? This is row 1. For row 1 you got some y, which could be 1 or 0. For row 2 you got some y. Assuming row 1, row 2 all are independent, I want a I want the probability, cumulative probability, the total probability of all the rows. So what we do, we multiply them. Why? Because we have assumed that the way we did it here, this we multiplied. So let me write it here. Theta. Do not go on to this notification. This means multiplication. The summation is known as this way. This is multiplication. ये कह रहा है कि we are multiplying the probability of all the rows number 1 to n as theta x y 1 minus as theta x 1 minus y. Now if you do that, now this is probability, and you remember, or if you do not remember, there is a thing. If you multiply, take if they are even, like probability of, if they are even like event a, event a b c, log of a dot b dot c is same as log of a plus log of b plus log of c. So, so this is how you can convert multiplication into summation. So when we take the log of this number whole, this becomes these things become plus. So all the events would be now summed up, and we also take the log here. So take this term here. So if you take the log of this term, log of a raised to power b, this part is b, this part is a, this is equals to b log a. So therefore we see the yi part came here and log of this. Similarly, 1 minus yi part came here, log of this term. So basically, for the easiness of mathematics, we converted the product into summation. It becomes yi log of hxi plus 1 minus yi log of 1 minus xi. Just be there with me. Now guys, now just a moment, let me write it here. I will re-revise it again once, then this thing will start making sense. I equals to 1, and this is log of h theta x plus 1 minus yi log of 1 minus h theta x. Right? Now if we put y equals to 1 here, this whole term will boils down to this part. If we put I equals to 0, this whole term becomes negative. This will boil down to 1 minus 0 is 1 log this term. This term we want to increase. We want to maximize this term. We want to this is known as maximizing the log likelihood. But gradient descent is a problem which works on the minimize. So maximizing the log L theta is same as minimizing the minus log of L theta. So therefore, here maximizing this is same as minimizing the same term. I put it minus, and we want to minimize this cost function. Minimize this cost function. So our cost function of logistic regression boils down to this term, log x theta x minus log 1 minus x theta x. That is it. That's the log function. That's the cost function which we're gonna use that. So I'll repeat it once again, and then now things will start making sense, and we will not go more into this part, all this mathematics. What I want to convey here is that, okay, so what I want to convey here is that we have all the experiments. Row 1, I'll put it here. There's some y. Row 2, y. Row 3, some y. So on. This is all the data. We already assume the concept that my all the rows are independent among each other. So I wanted to calculate the probability give of the whole data such that given all the rows, The corresponding value of y, the corresponding value of them is gonna be y. So we wanted to convert the we wanted to calculate the probability of this whole, all the rows. X means all the rows, capital X. So let's write it this way: probability of y given all the rows and their theta. This is now we want to do it for all the examples. So this boils down to multiply, because we have studied that probability of ht is same as probability of probability of probability of t. So we multiply. So therefore we multiply all the events. So from I equals to 1 to n, probability of yi, probability of yi given the row. Xi is nothing but the row and their corresponding theta. This is first thing. We are multiplying the probability of all the rows. Second step, this thing. This thing can be written as, this part can be written as this part. This is the only thing which I wanted to focus here. I'll write it again. Probability of yi given x theta is as theta x. So though we are writing two terms here, but it at the end this is just one term. For example, if output of that row is 1, y equals to 1, you put it 1 here, you put it 1 here, 1 minus 1, so this thing will always cancelize. So therefore probability of when y equals to 1 given x theta is always x theta x. Similarly, probability of y equals to 0 will always be 1 minus s theta x. So just to these two equations together can be formalized into just one term. That's what is happening here. Nothing to be memorized, but this is exactly what these guys are doing it here. And then we take the log, because we cannot multiply, we cannot work with the product. We convert it into summation, and log of product is nothing but the summations. So this eventually this everything boils down to this thing. So your cost function is minus log of x. That is it, of s theta x for y equals to 1, minus log 1 minus s theta x for y equals to 0. This is a cost function. In linear regression, this was normal mean squared error. Now let's understand the intuition behind that. See, if my y is equals to 1, if my y equals to 1, s theta is 1. What it means is that my actual is 1, my prediction is also 1. It means my cost is 0. But as s theta x tends to 0, it means your cost is infinity. So this says that if your production is 0, but actual is y, you're gonna have the higher penalty here. This says that your prediction is 0, but actual is 1, your s theta x is gonna very high. The cost is gonna very high. That's we are doing it here, nothing else. We will penalize the learning algorithm by a very large cost if you are doing otherwise. Your prediction is 0, actual is 1, you're gonna have the large penalty. Similarly, if your prediction is 1, your actual is 0, you're gonna have the large penalty. That part is getting captured here in this cost function, and that's what we want to reduce. We want to, if when the cases where y equals to 1, we want to reduce this term. When y equals to 0, we want to reduce this term. So eventually your cost function, we gonna do the sum over all the examples, 1 upon m, take the cost, calculate the cost based on this thing, and sum up. So row number 1, if my y is 1, I will calculate a j value, which is minus log of s theta x. Row 2, if y equals to 0, I will pick this term, calculate this minus log 1 minus s theta x. At the end, we will sum up all these value. This becomes your final error value of cost function j. So that's how we do that. So in terms of, this is logistic regression, this is linear. Let's say how it is different. Here the cost function was 1 by m y minus s theta x square. summation. This was the cost function. Here the cost function is same. Only different is that instead of mean squared error, the cost is given by minus log of s theta x for y equals to 1 and minus log of 1 minus s theta x for y equals to 0. This is how we will sum up. So this is not squared. This is not some squared function. These are logs function. So in general, the cost function of a logical regression are the log functions. That is it, and that has been derived from this proof. This proof. So this proof, understanding this proof, maybe it's okay. I mean, I can reiterate again, but the final thing which is required to know is that here, that how the cost function is derived. If this cost function is derived, now your objective would be to reduce this cost function over the training the model. So this is a simple logistic regression cost function. We started from x, y. We understand the sigmoid function. Then we formulate the problem that given all the rows, all the y, I want we want to maximize the likelihood of all the thetas which are responsible for this relation, this x and y. Therefore, we calculated the probability of complete y given x, now which is nothing but the multiplication of probability of all the rows given x. Then we take the log because we cannot multiply by log, multiply by product. So we convert this term into summation log of p raised to power x. Or when we do that, this thing boils down to these two terms. Since this is discrete, y equals to 1, we take this, y equals to 0, we take this. This becomes a cost function. Now next goal would be to keep doing the iteration, calculating the cost function until we reach the lowest value of this cost. That we gonna do that. So I know this is little, but yeah. So let's start from all the doubts and what we should reiterate again. Anyone?
Yeah. Sorry, Raj. Can we have a short break? Maybe.
Yeah,
For
sure.
Yeah,
two.
Of
after
course.
break, I guess we will
Oh,
we can
we
start
already
again.
it's 8:46, right? I already crossed the time. Anyway,
Yes.
so yeah, let's take question and maybe let's do it again. I mean, it's okay we do it couple of time until we understand how we are reaching there. So
Yes.
yeah,
Yeah.
so just a moment. Keep 8:40. Okay, let's meet at 8:55.
Okay. Yeah.
Okay, okay. See you then. Yeah. Hi guys, so I just written some steps. So once you are back, maybe we can have a look.
Yeah, you can start. I think.
Okay, so
Can start.
before questions, I just again will take you to the steps again. Uh, Step number one. Initially, we calculated our x theta x hypothesis. We take the sigmoid function. Sigmoid function also represented by this symbol sigma sigmoid, which is 1 upon 1 plus e raised to power minus z. Z means your theta transpose x. So this means if probability y equals to 1, this is nothing but s theta x. If probability y equals to 0, 1 minus this, which is 1 minus s theta x. This is step number 1, equation 1. Step 2, if y equals to 1, y equals to 0, so we simply combine or write them together in the mathematics, which is nothing. Probability of y given x is this into this term. Why this terms works? You put y equals to 1, this term becomes 0. So basically, this boils down to same thing. Given p equals to 1x s theta x. So y equals to 1, this terms will remain, this becomes 0. Now, given y equals to 0, this terms becomes 1, this terms will remain 1 minus s theta x, which is same as that. So what we did it here is multiplying these terms with this y 1 minus y is nothing but the simple way of representing both these terminologies here in one term. Step number 3. After doing that, we want to maximize the likelihood of data. So I want to reiterate this term. Maximize the likelihood of data. This term says that, see, you have provided me all the rows with the y. So what is that? I want to maximize the likelihood of data means given this rows and the y, what is the probable best set of thetas which are responsible for this data. So by saying that maximize the likelihood of data means maximizing the chance of getting that probable theta for which this row combination of these row y exists. We want to maximize this term. So when and this boils down to the term probability of heads has t. I multiply all the rows. So I means rows. We are multiplying. We are calculating this term for all the rows. For row 1, we calculated this term. For row 2, we calculated this term and we multiply them. Now, multiplication is hard because if we use just this term, it is very difficult to differentiate them. Doing a differentiation of a product term is very difficult. Therefore, easier is to work with the log, with the sum. And how we convert product into summation? Just take a log. So log of L theta, we will take the log of that. All the terms become summed up, and this will break into this term yi into log of s theta x. This is how we expand a log of this term plus 1 minus yi log of this term. So this becomes two term 1, term 2. Maximizing this thing, maximizing the log of L theta is same as minimizing minus log of L theta. Now you would say why we are not working with maximizing this log L theta, because it is easier to reach to the lowest. So gradient descent works with the minimization. Therefore, saying maximizing this value is same as minimizing the negative of that value. Simple mathematics. Therefore, we call it as a cost function, which is nothing but the summation of minus 1 by m. Same term preceded with a minus. I so if we put it minus inside, this is minus. So which boils down to the cost function in just two way. If y equals to 1, my cost function value would be this part with minus sign. If y equals to 0, my cost function value would be this. So this y is 1, this becomes just log of s theta x. If y is 0, this just becomes log of this term. So finally, this is how we decided our our cost function value will. So this becomes our cost function j for all x, all the rows belongs to all the rows. So this is the cost function of a cost function of a logistic regression. So that is what we try to derive from one by step by one, and finally we boils down this term. So now, any question? I mean, there must be definitely questions. So let's hear that. Anyone, any question there?
Maybe everyone are trying to understand before asking the question. Maybe same is with me. I'm just trying to.
No, no issue. So at least everyone is okay till the part we this term when we applied the sigmoid function, because this sigmoid function boils down everything
Zero and one. Yeah.
0 to 1 for some this number
Yeah.
point 0.5.
Yeah.
Now we
So,
this yeah.
mhm.
Mhm.
So, let's say like I'm having row number one. So, whatever the outcome, that is y hat for that particular row. So, you are saying that each row element, I'm applying this sigmoid function, I am converting y hat to either one or zero, correct?
Yeah. So basically this is how you do. They are row 1 some x1s x2 x3 is given and y is given xn theta 1 theta 2 theta 3 theta n. You calculated x1 theta 1 plus x2 theta 2 up to xn theta n. Let's call it this term, uh, we call it theta transpose x. And then whatever this number came up, you put it into 1 plus e raised to power minus this term, whole number. This will give you a value or sigmoid value of something in the range of 0 to 1. So this is what we get after passing from
Okay.
sigmoid function. And
Mhm.
now this you're gonna do for for all the rows.
Okay. Up to here. Okay.
Okay,
Uh,
so this part is here now. Next main point is that okay, we did it for all the rows. Now how we come up with the cost function? That's the next and the only question. How we come up with the cost function?
okay.
So therefore for that, what I decided in the step, understanding of likelihood is important. So likelihood is the term which I want to repeat again. Likelihood of the parameters. So this term says given all the datas, given all the data and their corresponding y value, this data we do have in our system, in our data provided by user. What is the likelihood of this data given some parameters? So this says that assuming the n training examples are generated independently, we can then write down the likelihood of the parameters. Likelihood is nothing but chances that HHT comes together. What is the chances of that? The chances of that is we multiplying them. This is the likelihood of getting HST. In this case, this is fixed 1 by 2, 1 by 2, 1 by 2, which is 1 by 8. Always the likelihood of getting HST would be 1 by 8 in this case, right?
Yes.
But in our case, we do not know what is the theta, actual theta, right? There could be multiple thetas, set of thetas, right? And we want to increase that likelihood. I mean, as a possible best set of thetas which we want, for that, probability of having given the input, getting those values are higher. That's likelihood which we want to achieve. So we work the same way which we do for HST is nothing. We multiplied the probability of all the rows. That is it. Probability of all the y given the rows. That we multiplied that. And this part is very easier. It's just a way of writing, which I already mentioned. If you're the single way of writing this term is as theta x raised to power y 1 minus as theta x raised to power 1 minus y. Why this term can be written together? If y is 1, this become 1, 1, and this term becomes 1 minus y is 0. Anything raised to 0 becomes 1. So this boils down to s theta x, which is this is when probability y equals to 1. And you know when probability of y equals to 1, then probability of y equals to 0 is nothing 1 minus this, because probability is always sum is 1. So
Mm-hmm.
that becomes the second term.
Okay.
So but for the mathematics, it's easier to write it this way. Now you cover all the cases where y's are 1, y are 0. Nothing that
So now 1 to n are my rows,
but 1 to n
total
is your
rows.
rows. 1 to n is your
Okay.
rows. And see the same thing. Probability of h. This is probability of h. Probability of t is what? 1 minus probability of h. That's what we are something doing here. Probability of y equals to 1 is this, then probability of 1
Mm-hmm.
minus y would be 1 minus that number. So this is
Okay.
nothing but a mathematical representation of writing that.
Mm-hmm.
After
Okay.
that,
Now I'm summing. Sorry, not
products.
uh, m- taking product basically. Yeah.
Why? This way.
Yes, yes. Product. Yep.
Yeah. So because we assume that all the examples are independently generated.
Yeah.
Therefore,
And one more question. Like, see,
mhm,
so I can simply take multiplication of probability. Why I am again doing here one minus that
uh,
probability means
all
probability of not coming. Why we are doing that?
because you want to cover all the cases. In your cases, the
Mm-hmm.
y would be 1 and 0. So here you are covering all the cases. For example, for row 1, y is 1, right? So if you put one
Yes.
here, if put it 1 here, this term will come 1. So basically you are just taking one term, right? Y equals to 0, y equals to 0, this term will work. So eventually there is just one term. You are multiplying one term only. It's just the way of writing that. Got it? So because this yi is playing the part. Just a moment. Yeah. So it's just one term eventually. For all the rows, this is just one term, nothing else. When y equals to 1,
Okay.
this one term will stay. When y equals to 0, only this term will stay. That is it.
Okay. Got it. Got it. Means you are saying that naturally one term is going to
Naturally,
be
one term will there.
vanish. Vanish. Yeah.
That is what I was trying to amplify here. When I take y equals to 1, then
Mm-hmm.
this term will go away.
Okay.
When y equals to
Correctly.
0, this term will go away. So eventually only one term will stay. One probability will
Okay.
stay, right? So
Okay. Fine.
now we need to increase the likelihood of this data. Product के साथ work करना is very difficult because you cannot, the differentiation is very hard. To make things easier, we take the log of both. Just
Okay.
that,
We just now we put log on both sides.
yeah.
To
And
yeah.
assumption is very simple. If you want to increase the maximize, if you want to maximize the likelihood of L, then
Mm-hmm.
maximizing the likelihood of log L is also increased. It's monotonic. So we take
Okay.
the log. When you take the log, all the
Mm-hmm.
terms, all the terms multiplications converted into plus.
Okay.
Y high comes outer. This is how log works. I mean, now,
Okay.
let's not go here. But if you take the log of v raised to power a, this is gonna be a log raised to power v. This is a mathematics. So yi comes here, 1 minus yi terms comes here. This becomes log. Now things become very easier. I want to maximize this term, but gradient descent works with the minimization. Therefore, maximizing L of theta is same as minimizing minus L of theta. Almost same mathematically. ठीक है?
Okay.
And after this becomes very easier now. When if y equals to 1, this becomes 1, this becomes 0. So only this terms remain. When y equals to 0, only this terms remain. And that becomes your cost function. That is it. So if you take care if during the experimentation, if you calculate the cost function this way, this means you are taking you are taking care of all the rows for which y were 1 or y were 0. So eventually this is the thing which we want to minimize. If you minimize this term, this will make sure that for the cases when y was 1, your thetas will take the cases where y appropriate tends to 1. That thetas will come up. And when y is 0, this term will take care and modify the thetas in such way that your y hat tends to 0. So only thing which we, if nothing, I mean, if we are still not able to comprehend, this is what we need to know. That finally our cost function boils down to these terms, and these becomes the part of our next. This is what we want to minimize, the way we minimizing the mean squared error in linear regression. Here, this is a term, log functions. That is it. But the whole derivation is little, I mean, one by step, but eventually
Yeah.
just boils down to a log function.
Mhm.
It's very simple. It
Yeah.
boils down to log function.
Derivation I maybe understood as a concept, but I'm just struggling with the cost function now. To maybe I'm trying to correlate back in mind with the this. Uh,
you need to
Sum up
focus
least square.
this thing.
Mm-hmm.
You need to maximize the log
Maximize the
likelihood.
log likelihood.
uh, in mean squared error, so everyone in mean squared error, we have the numbers with us already.
Yeah,
But
yeah,
here
yeah,
here we are dealing in the terms of probability.
yeah,
So
correct.
we want to increase the chance overall. So we
Mm-hmm.
want to
Mm-hmm.
increase the chance. If this is the data,
Mm-hmm.
for that this was the y. So
Okay.
what is the probable likelihood parameters for which this data will have this y? So basically you want to increase the chance of those thetas who are more likelihood to have this data in the y combination.
Okay.
So
Mm-hmm.
it's just that. So in any kind of problem, you will see when you want to increase, you want to find thetas, you have to maximize the log likelihood. Log likelihood is nothing. It's just is just that all the rows which you have provided to me exist together. In this example again, I want to mention HHT. This is pretty much clear to me because the best log likelihood is given by, which is 1 by 2, 1 by 2, 1 by 2, 1 by 8. This is always gonna 1 by 8.
Okay.
In our cases, it varies. It depends on theta, right?
Okay.
So
Mm-hmm.
मेरे को
Yes.
इसको increase करना है. That will give me the best set of thetas. Just say
Okay.
in linear
Okay.
regression, I want to
Mm-hmm.
decrease mean squared error to give me the best thetas. Here, I want to increase this likelihood to get the best thetas.
Okay.
But
Means basically we are increasing the probability of our result.
yeah, you are increasing the probability of this combination of this data and y.
Yeah. Yeah. Yeah.
And when you do
Okay.
that, you will eventually end up with the best thetas. How,
Okay.
yeah,
Got
so
it.
but this is maximizing the log likelihood. But as I mentioned, gradient descent works with the minimization. So maximizing of L theta is same as minimizing of the minus L theta.
Yeah.
So if this is how we formulate our problem, and this whole term boils down to this term: minimize this cost function. While doing so, you will reach the best thetas. So this is a logic equation. I mean,
Yeah. Yeah. Okay. So
so
maximizing in the sense we are saying that we want a maximum probability
maximum
for the
probability
combination we are
o-
looking.
of all the rows. So yeah, this is
Yeah.
exactly what log like the likelihood is saying that, right? And by doing so, you will get the best thetas. And
Okay.
fine, yeah. So yeah, guys. So I think what about everyone? I think hopefully at least 50% things would be making sense that how we moved sigmoid function. I'm pretty much sure everybody understand how we able to convert that into a range of 0 to 1. But after that, how we moved to generate the cost function, I think 50% should be okay with everyone.
Yeah,
Still,
now I think it's more clear than what it was first time. Yeah.
yeah. So of course, this will take some time to comprehend. But over the time, if you have a revision, if you see some videos, everything will start making sense. It's just that the the ideology got changed here. Here the things in linear regression were pretty much straightforward. We wanted to reduce the cost function, number minus number, reduce that. But here, and as you mentioned, that here we are just taking about dealing about the whole data. I want to increase the chance of this data. So basically maximizing that chance that if I multiply all the rows, this is the highest probability. While doing so, we would be able to reach the best set of data, and that's what we are doing it here. Okay, so and anyone and just keep this thing in the mind and maybe read again. But if nothing boils down to us, only thing which we need to take care of it is that the cost function of a linear regression is nothing but a log. That is it. It's that simple. Log is the cost function minus log of your s theta x, which is what theta 1 x1 theta 2 x2. उनका log लेके with negative sign, that is cost function. In cases y equals to 0, we have to do minus log of 1 minus s theta x. So yeah, if this is clear, now let's go to the next point. And what's the time? Just a moment. Okay, so just one example here. Again, this is same as what we see in the linear regression. This is my cost function, summation minus yi log I 1 minus yi log I. While doing so, yi is what? S theta x. This is s theta x. This is s theta x. This is s
Can you
theta
go back
x.
one slide a minute, please?
This one.
Yeah, here.
This one. Uh,
Minus log h and minus log of one. Okay. Just one question. Um, Now
mhm.
here we are doing this 1 upon m because we have m samples and we need cost of each uh
We are
cost
averaging
for
out.
each theta, right? Yeah. Okay.
The same way we did the we did the mean squared
Mean
error.
square there. Yeah.
So
Yeah.
this is also because eventually we want to come up with one number. So we take the calculate for all the rows.
Yeah.
We sum up, and we take the mean.
Okay.
So and so this whole term, if you write it together, this is how it looks like. yi log yi I already shown us. So when y is one, this term becomes 0. Only these terms remain. So y becomes 1 only, minus log of yi remains. Basically, your this term. Similarly, for cases where yi is 0, this terms off, this terms become 1 only, log of 1 minus y. Basically, this term. So that easy it is. Now, we already, when we see the linear regression, we understand that there are some.
This in
Mhm.
previous equation, here I could understand this yi, but what is here h theta and x?
As theta x, I mean, as theta x is nothing but theta 1 x1 plus theta 2 x2, theta and xn, right?
Okay, 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 okay,
Hmm?
okay, okay. It's y
Sometime,
hat only.
yeah,
Yeah.
it's why sometime it's hypothesis, sometimes it is y I had, and likewise.
Okay. Notations are complicated. Yep.
But hypothesis, if I while driving, we use the term as theta because it is denotes hypothesis. H for hypothesis, right? In our cases, hypothesis. So we started seeing here. This is our hypothesis. After calculating all the theta one, take the sigmoid. So remember, in logistic regression, the sigmoid function after giving the input theta transpose x is the hypothesis, which is nothing but same as y hat. Linear regression, it was pretty much simple. Linear regression, it was hypothesis was just here. It's just a wrapper. We applied sigmoid on top of that. That becomes our s theta x.
Okay, okay.
So yeah. So
Thank
everything
you.
is same. These two are same terms. Just add it up here. Eventually boils down to one term. Now what I want to say is that the term which we see in the linear regression, that we also want to improve our model. So there's term known as we added one penalty here. This is theta's. So basically, sometime what happens? Some of the columns, some of the futures, x1, x2, we have x100. Some of them are not good to us. I mean, they are not helping our model. So we want to penalize our model in such a way that suppose if x5 is not working, then that theta 5 should be lesser. These columns are penalized. I mean, if some of the features are not working, you have to penalize that columns. How we do that? In linear regression, we saw there that was RIS and lasso. RIS, if you remember, RIS was we take the L2 norm penalty. Here we take the L1 norm. But if you do not remember that, that's okay. What we do, we added one more term, which is nothing but the summation of all the thetas ka square. And we added this term in the penalty. Now see how this term works. If some of your thetas are very wide, then these terms will explode. So eventually your loss will become higher, which means, which is true. If some of my thetas are not working well, my loss function should be higher side. That loss function will increase. So by adding this term, we tell our model that penalize these thetas always such a way that if some thetas are not improving, you reduce their values. So we added a penalty term. This is known as L2 penalty. L2 means square penalty because all the thetas, the square, we are adding it here. J equals to 1 to n. So if this is, we are just working with say uh, x3 theta 3 up to x10 theta 10. We are working with 10 features. So this equation will become minus 1 to all the rows. Suppose we are working with 100 rows. We have so our data looks like row 1, row 2, 100 rows, row 100, column 1, column 2, column 3 up to 10 columns, 10 features. This is my data looks like. So this term will come like log likelihood minus 1 raised to 100 terms yi log of yi, where I is a row, plus 1 minus yi log of 1 minus yi plus penalty term lambda by 2 summation column 1 to column 10, 1 to 10 इनका थीटा, थीटा 1 इनका थीटा है उनका स्क्वायर. तो जो भी कोफिशिएंट है, if it is 0.02, if it is 0.0, it is 1.2, if 1.6 is 0.5. So this term will become some lambda by 2, 0.02 का स्क्वायर plus 0.0 say 3 का स्क्वायर plus 1 का स्क्वायर, so on, last वाला 0.5 का स्क्वायर. So a term you added. So this term is known as penalty term. These terms takes care of your thetas to be get penalized if they are not contributing into the model or their values are increasing too much. If their thetas are over exploding, for example, the value start going to 5, 10, these terms become huge. If this term becomes huge, my whole loss becomes huge. And when loss becomes huge, it tells the model indirectly says that, see, with this set of parameters, your error is increasing. So work on your parameters. So that's the way of telling a model improve their thetas. So by adding a regularization term using L2 penalty, L2 stands for L2 norm, which is nothing but the square. If you would have used the L1 norm, this term will look like theta absolute. So plain. But here we works with L2 norm, right? So L2 norm, and so that's how we penalize our model or regularize our model learning during the training by adding a penalty terms. Penalty terms finally takes care of the thetas. Indirectly tells the model to improve the thetas which are not working. This is what I wanted to edit here. Yeah. So any issue with this term? So this cost function is already there. It's just that we added one penalty term. This is for the just for the learning that how this penalties helps us improve our model training, because it penalizes the thetas, it penalizes the futures via the thetas which are not performing or which are not useful to us. So in let's read what here. Sometime our models become too complex that is started memorizing the data point rather than understanding the nature. Sometimes too much correlation attributes makes our model stable. Means we forget to add or remove the multicollinearity. If there are too much multicollinearity in our data, many features having relationship with other features, or at last, if some of the features are not important to us, how we take care of this thing in the training? We take care in this training by involving bringing the techniques of regularization. Basically, restricting the involvement of not important attributes, the features which are not helping the system model training. So we apply regularization techniques, which is nothing but a L2 norm. That's what we did. And same thing we did in the linear regression. In linear regression, we did it two way. One with the L1 norm, which is absolute, one with the L2 norm, which is square. So, same techniques we apply here, right? And so I think, yeah. So learning so far, and we see we initially we see how we create a hypothesis. We understand that applying a sigmoid function, applying a sigmoid function will bring my output in the range of 1 to 0. Then we understand, okay, given the data row 1, row 2 up to row 100, and given their corresponding y 1 0 0, we we calculate the probability of y hat for all the rows and multiplying that. Why we do that? This is known as term likelihood. As the name suggests, likelihood means that what is the probability of this relation of this data with this data. If we increase their probability, indirectly we are finding the best thetas. This is what we are doing. By doing so, we come up with a cost function which was nothing but the log, negative log of y hat. Sometime I write y hat, sometime I write s theta x, or 1 minus log of y hat. So this is a very simple cost function of, and then we apply this cost function, understand the terms of this penalty, a kind of improvement. If you even do not do that, that's okay. So finally we find the boiled one, and late after that we gonna apply the gradient descent on this. We calculate the j, then we calculate the derivative of this cost function j with respect to theta 1, and then we update our theta. If you remember, theta 1 minus theta lambda, this derivative. This we do, this will keep doing for all the thetas, which is same as the gradient descent which we do for the linear regression. Only thing which makes differentiate linear regression from logical regression was the business problem and the cost function. Right? And and then we keep on applying gradient descent until it converges. And concept of convergence remains same as what we see in the linear regression. The only point which you need to reread again is the how the cost function j. That is it. So linear regression.
In this linear regression where we are applying penalty, na, so here we were like trying to selectively bring down the my theta, okay, by uh,
This, yeah. So you will agree.
subtracting this, yeah.
Yeah,
But
you
here
will.
how we are doing that?
Mhm. So
Because there
here,
we are selectively choosing the theta
yeah,
one, two,
with
three.
the help
Here,
of lasso. In rich, so this is basically raise where you penalize the theta. This theta will not become zero. It would tends to zero. Now see how it works. Higher loss, high loss is bad. If suppose in theta summation, theta 5 is very bad. It's very high. The whole
okay,
sum become high, right?
yes, yeah,
Adding this term, adding this higher value into cost function makes it high,
yes,
which says that my model is not learning. Cost is becoming high. So
okay,
next time when you take the derivative of this with respect to this theta 5, right?
mm-hmm.
That gonna change a drastic change in the theta 5, right? Now this j value is very high. Now when we update this term theta 5 minus and take the derivative with respect to theta 5, this term's gonna decrease hugely because this terms have become huge. So theta 5 will be updated more. So just by adding one regression term, regularization term, you are penalizing this whole loss function, and this terms becomes huge. So theta 5 will reduce drastically. Basically, and it means basically becoming improved version of with respect to previous theta 5. So it's just that. It's just the ideology that higher theta, higher cost value, bad. So if these terms are small, it means we are doing good. But if these terms are high, we are doing bad. So model will understand that these terms are becoming increase and increase in every iteration. That model is not learning. So basic, therefore, adding a penalty terms helps you decrease the decrease the cost function. So that's why they are known as regularization term.
Okay, got it
It helps
now.
regularize. So
Okay.
final, guys, before leaving, just couple of slides there I'll cover next. But before going, a quick one comparison: uh, linear, logistic. Uh, we predict continuous data. We predict category. Cost function was mean squared error, which is given by 1 minus m yi minus y hat square. Here the cost function is minus log of y hat. 1 minus y hat log of 1 minus y hat, which is just nothing but the one term. One will disappear. In other case, other will disappear. Here, after doing so, we apply gradient descent in both the cases. Gradient descent till the convergence. That is it. So that's the only difference. Continuous category, we break category, mean squared error, cost function. Here the hypothesis was theta transpose is. Here hypothesis was sigmoid of theta transpose is. Maybe I will add one slide here, a parallel comparison, and then that's therefore then you can relate that how the things changes from linear to logistic regression. Okay, so I think we can close for the day. In next class we gonna see some evaluation metrics, how to figure out which model works best. Then we gonna work on some evaluation metrics, for example accuracy, recall, precision, f1 score. This we understand. That is it. Once that is done, we would be having a hands-on of linear regression, and then we would be having the mid-sem. So I think that's only gonna be the course of mid-sem linear regression, logistic regression. However, time permits, we gonna start a new algorithm, mm, uh, again from the area of supervised. So idea is to take four algorithms from the area of supervised and two algorithms from the area of unsupervised, and then we're gonna move towards the Gen AI. So this is the plan. So if nothing there, so please have a read again, just the slides, couple of YouTube shorts if you can see, just to understand logistic regression. But everything will boils down to what I have taught here right now. And the middle part, if difficult, we can avoid that part where we are doing the derivation. Only thing which needs to understand is that the cost function of logistic regression is nothing but a negative of log. That is it. So if nothing there, guys, we can close for the day. Good night. Take care then, everyone. See you.
Thank you,
Yeah.
Raj. Yeah.
Thank
Yeah.
you.
Thank you.
I'll share the slide right away. So have a look, please. Thank you. Bye.
Yeah, sure.
Yeah.
Thank you.
Thank you.